The chi-square test for independence tests whether one variable affects the probability of the other. So are the two variables dependent or independent? Now this section is on the chi-square test for homogeneity, and the steps are actually identical. However, the purpose and conclusion are different. So we are testing whether different populations have the same proportion of individuals with some characteristic. So again, all of the steps are the same as the chi-square test for independence, except for the hypotheses and the conclusion. So the null hypothesis always states the proportions are all equal. So P1 is equal to P2 is equal to P3, etc. And the alternative hypothesis states at least one of the proportions is different from the others. The following contingency table shows the observed results of 188 patients after being given a new medicine or a placebo. Calculate the expected frequency for each cell. At alpha equal to 0.10, is there enough evidence to reject the claim that the proportions of the results for medicine and placebo treatments are the same? Use the rejection region method and show all work. So for each cell, we have to calculate the expected frequency. So we need to take the row total, multiply it by the column total, and divide it by the grand total. So 31.66, 32.34, 61.34, and 62.66. And each of these are at least 5. The claim is that the proportions are all equal, and this is the null hypothesis. The alternative hypothesis is at least one of the proportions is different. Alpha is 0.10. The degrees of freedom are 2 minus 1 times 2 minus 1, which is 1. The critical value, if we refer to the table, is 2.706. For chi-square, we have to take the observed minus the expected, squared, and then divide that by the expected. And then add all of those up. And if I type that into my calculator, I get 5.11. So the picture looks like this, and chi-square would go right there. So chi-square is in the rejection region, which means we reject the null hypothesis. And the conclusion would be, at the 0.10 level of significance, there is enough evidence to reject the claim that the proportions of the results for drug and placebo treatments are the same.